For those of you who are super far away, I want you all to know that I'm wearing R2-D2 heels, okay? You can't say. Okay, now that we have that, okay, now we can start. So, hi, my name is Mey. I am a software engineer. I'm an infrastructure developer at Forder. I used to write mainly in Clojure. Now I do other things, but I do Clojure in my free time. And I'm a public speaker, I'm a mentor, and I love Star Wars. You can tell the shoes, the presentation, it's all out there. So, I know why you're here. You all want to develop a multiplayer online game. And even if you don't, I'm going to assume that this is why you're here. So, what is a multiplayer online game? It's a game where everyone is playing from different parts of the world online. And this is what it looks like. And that's what you want to develop. You want to develop Star Wars Battlefront 2, I'm sure of it. But it won't be what we're going to do today. Sorry to disappoint you. So what are we going to develop today together? It's going to be this, which is not as exciting, but it's pretty cool, I promise. So yeah, oh my God, I'm breathing into the microphone all the time and it's crazy, right? Should I stop breathing? I don't think so, it's a bad idea, right? So yeah, before we start talking about the game itself, let's talk about the game loop. So what is a game loop? This is how we handle the game in code. So first of all, we get the input from the user, and then we need to update the game entities. And afterwards, what we want to do is to render those entities back to the client. So if it's locally, this is how we do it. And then if it's an online game, the part of the update and the rendering is done by the server, and then the part of getting the input from the user is done by the client side. And this is the architecture of the game that I just showed you before, the game with the monkeys. What we do is we have on the front end React.js, and then we use a WebSocket library to communicate with the server. And then on the server side, we have Clojure. Now, that's what I'm going to talk about today, the server side, because I didn't develop the front end. That was done by a friend of mine. So thank you, Roy, for doing the front end for me. And now I'm holding the microphone because I keep breathing into the microphone and then it's weird. Yeah. Sorry about that, guys. Is it better? I think so. Yeah, okay. So, yeah, I was just saying that we're going to talk about the backend. So let's do that. Okay, so here are the parts of the backend that I'm going to talk about today. What we have here is, all the way down is the game entities and data structures, which is how we handle the entities of the game. We will talk about what are the game entities in just a little bit. And then we need the functions to manage the game state. Like what happens when a player moves around, what happens when a player collected an item. This is the game state. And then next we have the functions that handle the communication outside, right? On the server side, we need to decide what happens if a player collected an item, and then we need to send it over to all of the other clients that are connected. And then later we have the Websocket API, which is what is actually sending the information to all of the connected clients. Okay, are you ready? So, game entities, data structures. So what are the game entities in the game that we have today? Okay, so first of all, we have the collectible items. And I don't know if you can see it very well, but these are exception types. I don't know, I thought it was funny. It felt funny at the time. So it's just monkeys collecting exceptions, because I got a lot of those when I developed in Clojure, you know, that JVM horrible. I mean, fun. I love Clojure. I don't like the exceptions, so that's it. So yeah, we have the exception types. For every monkey, there is an exception type, and the monkey needs to collect an exception that is matching his exception type. But in general, it's just collectible items. Then we have the players. We have different monkeys going around the screen, like I said, trying to collect those exceptions. And for every client, there is one player that has a crown on his head, and this is like the self client, which means this is the actual user that is playing the game at this client. Okay, so let's take a look at the data structures in Clojure. So first of all, we have the different exceptions type. It's just a collection of strings, which then later I randomly choose one of them in order to determine the exception type of the player or an exception type of, an item. Then the next thing that we have is two atoms where I define the items that are collectible, and then also the players. For those of you who just went in, I don't want you to miss on the game. Should I wait for you to sit? Do you want to know what the game looks like because you just walked in? I'm going to be super nice. Look, how cool, right? Okay, so I'm going back to talk. I informed all the ones who just walked in. So we have monkeys. The monkeys are collecting exceptions, and the exceptions have to match the type of exception that they have on their head. Crazy, right? So, yeah. Okay, so we have the items, we have the exception types, which are strings, like I said before. And then now we have the items collection. And this is just a collection of key map values, and the key will be a unique ID that I randomly generate, a UUID actually. And then we have the players collection, which is also a collection of key map values to describe a player. Let's see what a player looks like. So this is what it's like. We have a connection map as the key, because in Clojure, everything can be a key, even a connection map. And what is a connection map? This is the actual connection of the Websocket API. So this is the key of each player. This is how I identify a unique player in my players collection. Then what I have is the player's values, because this is how I describe where the player is at, X and Y. This is how I describe the score of this player. And also the player, do you remember? He has an exception type. So also we have an ID. Now, this is hard-coded because it's an example, but obviously I am actually generating the UUID for each player. Okay. Oh yeah, one more thing. I want you to notice that the X and the Y is values between 0 and 1. That's actually kind of cool, because this is how I don't need to mind about the window size of each client, because I just randomly generate a number between 0 and 1, and then later on the client side, what he does is he multiplies this number with the window width or window height. And this is how I adapt those values to the client's window. So it's relative. So all clients will see the location of the players the same, no matter what the window size is. Okay, now let's talk about the game state functions. We talked enough about the players thingy. I'm sorry, I'm super excited. So we talked about, we talked about the player key map value, and now let's see how we manage the game state. So we have a function. It's called update game state. Makes sense. And in that function, let's see what we have. So first of all, we get as an input the connection. Do you remember that I said that this is the actual connection of the Websockets API? So this is how I specify a unique player. So I'm getting the connection, and then I'm also getting the player steps. So these steps, this is the input that I got from the client. Then what I do is I check if this connection already exists in the player's collection. And if it exists, it means that it's a client that has already joined the game. So if it's a player that already exists, what I want to do is to call the function that is called move and collect, which does exactly what it says. It handles the movement of the player and the collection of the collectible items. So then, if the player doesn't exist in the player's collection, what I want to do is to add a new player. So let's jump into those functions. So this is the game state. These are the things that we want to handle. We have adding new player, player movement, player left the game, and then handle collectible items. Let's go one by one. So adding a new player. First of all, we have the getNewPlayer function, which does exactly what it says. It returns a key value map of the player. If you think that this is kind of familiar, well, because this is the exact map that I showed you before in the example. It returns a random value for x and y. You remember how I said it's between 0 and 1, because it's relative positioning that I'm using here. And we also have the UUID, and we have, show true. This is how I notify the client if this player has left the game or not. So when the client gets this key value map, he checks on the show key in order to check if we need to remove this player from the screen or not. And then we have the exception type, and last we have the collision. So the collision is used also for collisions with the window sides, or collision with items, or with other players. Okay, now let's talk about the add a new player function. So adding a new player, first thing that we need is to get the actual player key value map, which is what I showed you just now. And then we also need the connection. So the first thing that we need to do is to send self to the client. You remember how I said that for every client window, we have one monkey that has a crown, which represents the self, the actual user who is playing. So this is the first thing that I do. I want to use the send message function, which is a function that I wrote in order to wrap the Websocket API. And we will later on see what I did there. And so we are sending the new player map to the client. After we send self to the client, we want to send this client all of the existing players, because just in case a player decided to join in the middle of the game, I decided it's okay to join at any given time, but this is totally something that you can do differently. So when a player joins in the middle of the game, we want to send all of the existing players to this client, and this is what I'm doing here. Now, something that I want you to see is that I'm using dosec. So what dosec is doing, it's actually sending every player that is currently on the map in a different message. Is it the best? No, but I did it for simplicity. So this is one of the things that later on I can do in order to make this, better. Maybe I want to send one message with all of the players, but at this moment, for the simplicity, I'm using dosec in order to send each one of the players as a different message. Next, we have dosec again, because we also want to send all of the existing items to the player who just joined, right? We have all of the exceptions that are on the screen already. So again, what I'm doing here, I am sending every single item in a separate message. Is it the best? No, but this is for simplicity. So now we have the broadcast message function that is also the function that I wrote in order to wrap the Websockets API. This function actually calls the send message function that I showed you before. What it does is it sends the same message to all connected clients. And what we want to do is to send the new player to all of the connected clients. We want everyone to know that there is a new player who joined the game. So that's what we're doing in this line. And then lastly, at the end of this function, what we do is update player in map. We add the player to the general map of all players, and then that's it. Okay, now that we've added a new player, we want to update the player movement. So we call the move and collect function. So move and collect function, what it gets is the connection. Remember, this is how we identify a unique player in our game. What it also gets is the step X and step Y. And the actual values are either 0 or 0.1, which represents a movement, or minus 0.1, which represents a movement to the left. So 0.1 right, minus 0.1 to the left. Because remember, again, this is because I used the values for X and Y between 0 and 1. So what I use here is a thread first macro. That's the little arrow that you can see. I don't know how many of you are familiar with Clojure. So for those of you who aren't, I'm going to tell you what it does. So what actually you see here is that it takes in a value, and then there are multiple transformations that are done in every single step of this pipeline. And every single step gets the result of the previous step in the pipeline. And this is what the thread first macro is doing. So we start with the move player, which gets all of the, it gets the player and the connection and the step X and step Y. And then we have the collect item function, which actually handles collecting an item. If a player collided with a specific exception, it collects the exception, and then we need to remove it from the exceptions list. And then we see the broadcast message function again. Remember how I said that this function sends the same message to all connected clients. Now you see that this function is not getting an input. Well, it is. It's just the result of this function. So this is how it is. Like, we have this function, it collects the item. Now I have the updated player key value map, and now I want to send this map to the broadcast message and then send it to all of the connected clients. Okay, now what happens if a player leaves the game? Well, first of all, so long. Now, second of all, we want to handle this in the code. So we have the super simple remove player function, which is why it's not getting its own cool slide, because, I mean, there isn't much going on here. First, we need to delete the player entity from the player's key value map. And then we want to update all the players with the new game state. So look how it is. It's just swap is what doing the removing of the player, and then, hey, there is the broadcast message function again, which you already know. So next thing that we want to do is to handle collectible items. And here are the things that we need to take care of. First, we need to generate collectible items, which means generating key value maps of the exceptions that I said. I keep saying exceptions. We are all understanding that it's not real, like, code exceptions, right? It's kind of confusing. I'm generating exceptions on purpose. Like, sounds kind of weird. I'll just say items from now on, I guess. It would be better. Also for the video, so people won't think I'm trying to generate exceptions, for a living. That sounds pretty bad, right? So, okay, so first of all, we're generating collectibles. And how we do that, we just want to generate a key value map that will describe an item. Next thing that we want to do is to detect collisions. Remember how I said that collecting an item means that a player was had a collision with one of the items. It means that they had the same location at a specific moment. So then I need to handle the item when it was collected. I need to update the game state. So I need to update the player's map, to update the score. And then I also want to update the items map, which means to remove the item from all of the items lists. And then we need to update all of the players, which means all of the connected clients about the game state. Now, I want you to notice that this is a repeating pattern over here. You do something, you update something, starting, and then you update all of the connected clients. So this is how it is. If I want you to take something from this talk today, I want you to remember that this is the main idea when you develop a multiplayer online game. You want to update the game state and then broadcast the game state to all of the connected clients. That's it. I mean, okay, some game companies won't agree with me that that's it, but that's, you know, that's the essence of it. So, okay. Yeah, so I will just show you the code for handling collisions, because all of the other things are pretty simple. So the way to check for collisions is also very simple. You just want to check if there is an overlap between two squares, and, you know, all of the, if you type it on Google, there are so many results for that. So that's how I wrote it. I'm telling you all the truth here. So that's it. You just check if there is a, you know, a collision, and that's it. Okay. What is next? Network communication functions. Okay, so let's dig the. I love that GIF, by the way. Do you? Do you love that GIF? Because I do. Okay. All right, so you remember these two functions which I showed you before, and these functions, they wrap the Websockets API that we have in Clojure. So we have the send message, which actually sends the message to a specific connection, and then we have the broadcast message, which I already told you that it's sending the same message to all of the clients. Now, again, look at what I'm doing here. I'm using dosec in order to send it every single message and, you know, separately. And so I do, you know, I admit it's not the best thing. It's not, I don't know, it's not very scalable. But if it's your first game that you're developing, I would recommend starting simple and then going from there. At least this is what is good for me. I kind of think that it was fun also to do something simple and then try to evolve from that. So, last thing we need to talk about is the Websockets API. There isn't much to talk about because it's just an API that was given to me like that, like all APIs. Isn't it fun? So what we have over here is the WebSocket Routes, which is, this is how we are starting a WebSocket connection. It starts as a REST request, as you can see over here with the get all the way down. And then afterwards, it connects between the client and the server. And what you can see is that it is event-based. So on close, it removes the player from the player's map, and then on receive, which means when I get a message, it just updates the game state, which is the function that we saw a bit earlier. I mean, we're pretty close to the end, but not really. I just want to say a few more things. So first of all, let's talk about what we saw over here, because I do want you to remember that just because I showed you the code written in Clojure, it doesn't mean that you can't take this exact template and literally do that in any other language that you want. And I mean, you can go check out my Clojure code. I think it's beautiful, but some people won't agree with me. I don't know. So if you want to develop your own multiplayer online game, what you need to do is to start with deciding how do you want your data structures to look like. If you're, I don't know, if you decide to write your game in a object-oriented, why? If you decide to do that, then maybe you want to have, a class for your player or something like that. I don't like it, so I'm not going to tell you how to do it. But then if you're writing in a functional language, which is fun, I don't know if it's the best thing, but it's fun, then you just need to have key value maps to describe the players, and then the way that you separate each map from each other is by a specific key that defines whether it's a player, if it's an item. It's just a Boolean key that defines which player, which map this is that we have in our hand. So the next thing that we have is the Gamestate functions, and which I told you that is they move and collect in my case, but if you have a different game, then it's whatever other game logic that you have, this is where you'll handle it. And then you have all of the functions that you need to wrap the Websockets API with, because you want to decide how you want to send all of your messages to your connected clients, and then choose a good Websockets API. And when I say good, I mean good documentation, because that's what, I don't know, that's what it was for me. I found good documentation, good to go. So before we finish, I want to tell you that there are many challenges for writing a multiplayer online game, and I mean, there's a whole industry for that, right? And there are a lot of things that I can do to improve my game. Although I think it's perfect, I know it's not. So the first thing is, obviously, latency. I mean, I can send the messages in a more efficient way, maybe sending less messages. Maybe I want to serialize some of the messages to have them sent, in a more efficient way. Maybe I want to do a client prediction kind of thing. This is also a good idea, but it's a big challenge, and maybe that's going to be my next talk. I don't know, I didn't get to it yet, but stay tuned. The next thing that I'm interested in is scale. And when I say scale, first of all, it's a cool word to say. I don't know, why not throw it out there? Scale. It's a good talk already, right? I just said scale, that's it. But no, really. Because right now I'm an infrastructure developer, which means I do DevOps things, then I'm kind of intrigued to see what would it be like to handle game with multiple servers and multiple clients. What would it look like when I actually deploy it and not just playing on localhost? So that's because, I don't know, I think it could also be a cool challenge. If you have ideas, let's talk. And what's next? Tum, tum, tum. You go develop a multiplayer online game and tell me about it. Or get super rich, because if you do a super crazy game, there's a lot of money on the floor. Go pick it up, develop a cool game. And I mean, this is what we all want to develop, I think. But I don't think you can do it on your own. Be honest with yourself. But you can do this, and it's worth it, because it's fun. You can have cool monkeys collecting exceptions, even if it doesn't make any sense at all. Why would the monkeys want those exceptions? Why would anybody want to collect exceptions? Isn't it weird? Oh God, I have weird ideas, I know. And let's finish with that. Thank you.
Thank you, Mey. I think we have some time for Q&A. Let's start maybe with some questions that we have online. Do you see the question? I think you can see it on the other screen there. Basically, the question is, do you think game development can be useful for those that are learning functional programming?
I have a talk about that. My first Clojure talk was how I learned functional programming with game development. So first of all, yes, I think it's a good idea. And I'll explain why in one sentence. Well, when you develop a game, a very simple game, what you can do is you can concentrate on the idea that you want to learn. So for example, if I wanted to learn multiplayer game development. So, I wrote a stupid, simple game, and then I was able to concentrate on the networking and on the data structures management. And that's the same for when I want to learn functional programming. If I write a simple Pac-Man game, which is what I did, I mean, there isn't much going on there. There's one player and a lot of yellow dots. So then I can concentrate on the functional programming thing. I can learn that in a functional programming language, I don't have objects, I will have key value maps, like I mentioned before. And that will help you to grasp the idea of functional programming. So the short answer was yes, the long answer was also yes.
How did you create the animations for
Should I
this
tell
game?
you the truth? Oh my God.
Yeah.
So, okay, I'll tell you the truth, whatever. So there's a cool website, which I don't remember the name, but I'm sure you can Google this, where it just transforms into 8-bit kind of thing. So I ugly drew the monkeys, and then I put it into this website, and now it looks cool. But I promise, it was just horrible animations that I did. I can't even call it animations. It's insulting the word. It's like ugly monkeys that I put into that 8-bit thing, and now it looks cool, you know? But for the next game, I am using DALL-E 2, which I have access to, and now I have really cool characters because I didn't draw them. And, you know, a computer did it. I'm like, okay, good for you, DALL-E. You're doing a good job.
Would you recommend people that are new to Clojure to try and develop such a game?
Well, definitely, yes. Either this, like a multiplayer game, or like I said, a simple Pac-Man or Snake. You can totally go to my GitHub account and start from there and look for those simple games. All of the code is out there. My GitHub is just Lady May. It's very easy to find. And I'm sure that it will help you to get into Clojure. And you can also, you know, talk to me. I'll help you. I love Clojure. Come join the party. It's such a cool, all the cool people are in Clojure party. And you know, you see how I'm pointing myself out? It's so uncool to do that, I know. So yeah.
Any questions in the room?
So I agree that it's probably good to focus on simplicity at first, but I was curious if you had tried using like any Webrtc or anything to reduce the latency.
So I didn't try it. I did see a game that was developed in Go and did use, I think it was that, and it was way better. But I did, okay, that's not, okay. I didn't say that this is the best latency game when it, you know, in Clojure. Is it good? No. I didn't promise it's going to be good. I said it will be fun. You see what it says? I said it's worth it, because like fun. It's not going to be super fast. Don't think that this is how they wrote Skyrim, right? In Clojure.
Any more questions?
Great talk, thank you. I was just wondering, how do you handle, in terms of validating client inputs, or do you do any of that, or do you just trust right now that the client is not going to cheat in some way by having the character move really far in one time step? So
first of all, I mean, I don't actively do something to validate. I don't want to say trust, because I'm the only one who plays this game, you know. So I trust myself. It sounds really bad, but if I'm being serious for a moment, so first of all, the fact that I am doing all the logic on the server side, and the server is the one who's sending the game state to all of the clients, I think this is like the bare minimum that you can do. But cheating is a major thing, and you know, bigger companies than myself are handling this way better than me. That's actually a cool challenge to think about. And these are the things that I would actually handle specifically. Like if I want to do improvements to my game, it would be either like scale or cheating or so, because it's big things that you need to think about separately. So, yeah.
Questions?
We have one here.
Okay.
Woo!
So my question is, someone asked earlier, where in the, not necessarily in your game, but where in the model which you suggested, you put in the anti-cheating elements?
So where in the game or in general?
Well, not in your game in particular, but in the model you suggested for the game, right? Because you say that I can write any, basically any multiplayer game with following the same pattern, not necessarily.
Right. So I think, first of all, the cheating would be, okay, so for what I know on games in general, I know that they have both on the client side, and then if you do weird things, that it will disconnect you from the game. And then, so that's the first thing that you can do. just detect weird behavior, maybe have a decision tree doing something and checking if things that aren't supposed to be happening are happening on the client side. So that's the first thing that I would do. And then the second would be obviously on the server side. So maybe matching to other, maybe matching what you got, the input that you got from the player with what you expected to be getting from the player, something like that. So that would be right on the input time. That's what I would imagine that you should do.
Any more questions?
No, they all
Okay.
realize, smart people, come on.
Yeah, you can still catch Mey here at the conference, so yeah, feel free to reach out to her.
Yeah.
So let's give a warm round of applause